With some knowledge of pressure, now we can talk about a problem, which is force on a plane or plate. Here we assume the plate or the surface is a flat one, okay, a flat one, and a curved one we'll talk about later. We also simplify the problem by requiring rho to be a constant. If rho is not a constant, then the hydrostatic law should give us some variations, and I told you how to deal with that. So this is our problem. Let's say we have a tank of water, and here we have our plate. The plate itself is a flat plate, but the exact shape of that can be weird, okay? If we build our coordinate system, we can call this direction to be the y direction. The direction perpendicular to that is the z direction. And the x direction is perpendicular to the paper, right? We call this angle to be theta. So what I want to do now, I want to calculate the force of water. That is the force resulting from pressure, right? The resultant force resulting from pressure acting on our plate. Maybe we can call it to be FR. R stands for resultant. How can we get that? Well, as I have said, the FR is just the net force resulting from pressure, right? So it seems that we need to first get the pressure profile. How can we do that? Since rho is a constant, then it's very simple, right? Pressure just equals to gamma h. So if we define the depth to be h, then we can write out the pressure profile. So h first can be written in our coordinate system as y times sine theta, right? So obviously p is a function of y. It's just gamma times y sine theta. When we talk about a resultant force, we need to consider two things. First is the magnitude. The other is the point of acting, right? Point of action. So now let's focus on the first one, which is the magnitude of the force. So to get the magnitude of the FR is relatively simple. We just need to integrate the pressure acting on the surface, right? So FR is equal to minus the integration on the area A times the pressure, right? Something like this. You can treat this as a formula, as a convention of how we calculate the force resulting from pressure acting on a surface. Usually we define the normal of a surface to be pointing outwards, okay? So our normal direction of this surface is pointing outwards. But we know that the pressure is always acting inwards, right? This explains the minus sign. As I have said, this is the convention of how we express the force, and you can treat it as a formula. So we know the P is just this, so we can put it in, right? It's just the integration on A of gamma y sine theta times the normal and dA. Here we can pull out the constants from the integration. Gamma sine theta n are all constants. Gamma sine theta n minus the integration of y times dA. And what's y times and what's the integration of y on the surface A? I guess you are familiar with this notion before in other mechanics courses. This thing is called the first moment of inertia of the area A. This thing can be written as another form, which is called YCA, C stands for centroid or center of mass. Okay, so what is YC? YC means the y coordinate of the centroid of the area. Let's say this point is the centroid of the area. So in our graph, it should be this point, right? This point. And the coordinate of this point, which is this distance, is what we call YC, the y coordinate of the centroid, or the center of mass. So we can write this as minus gamma sine theta n YCA. But do you agree that YC times sine theta just indicates the depth of the centroid, right? YC times sine theta, again, we get the h, right? But this h is not just some random h, but the h of the centroid, right? The depth of the center of mass. So this thing, in turn, we can write it as minus PCA, right? YC times sine theta is just these two combined will give us something called the depth of the center of mass. And we multiply this by gamma, we get the PC, the pressure at the centroid, center of mass or centroid. So what's our result? It seems that we can only, well, first let's talk about the direction. The direction is indicated by the minus gamma, right? Minus normal. This is very simple to grasp because we know the pressure is acting perpendicular to the surface, and the direction outwards is called plus n, the positive n. So obviously the force resulting from pressure will have a negative n sign, negative n direction. So this is the direction. But the value is PC times A, right? It seems like we have picked out a representative pressure, right? Or an average pressure. So we can say the pressure at the centroid is the average pressure on the whole area, and multiplied by A, we would get the magnitude of the force resulting from pressure acting on our board.